Okay. The licking noises, by the way, come from my dog eating peanut butter from a spoon, so, you know. Apologies for the delay. No intro. You're jumping straight to it. Although, I haven't had breakfast, so I will be munching on my cereals. I try to be as quiet as possible. Let me tweet out a few things. I'm absolutely unprepared. I was so late today. Nope, we don't want that. We don't want to listen to anyone else's stream, do we? Okay, you're done? Excellent. I can put you on the bed. There you go. Cool, and I can get Windows up and booted, which I haven't done yet either. So, actually, no, I probably should need to tweet out that I'm also live. Right, so we're doing this. We're going to... Hello to the unprepared indeed. I'm so unprepared this morning, dude. So unprepared. What is this? Why does copy paste not work? Because I had a wrong keyboard thingy. Okay. Live on Twitch now. Right. Add another post. There we go. Anyways, good morning. How are you, Kakolaken Joe? Anything happening? Doing fine? Nice, nice. I mean, in a way, you can think of me being late as my April Fool's joke. How about that? Oh, actually, no, that's not the message I wanted. I wanted this message, and I'm gonna pin this one. There we go. Okay, as I said, I'm super late. I haven't had breakfast, so I will be munching my cereal. My PC just booted up, so I will be switching to the screen shortly. Let me just close a few things that always start up, which is annoying. Yeah, the shock. It's chaos. Chaos, I'm telling you. Okay. Where is my... Actually, let me already... no, let me close some tabs first. Right, don't need that, don't need that. Don't need that. Yup, yup, yup. Gonna keep these open because that is something that I looked at recently and which was today's topic, more or less. Okay. Nope, don't need that. Cool. Okay. Sorry. Yeah, let me switch to the screen. Input capture. There I am. Hello. We're gonna need the project, right? So let's go to project, GB assembler. And what we'll be doing is, because Alpha 2 has been released on my Ko-fi page, we're gonna just copy and paste this, right? This is my way of versioning stuff. There we go, Alpha 3. And we will be working on Alpha 3. So I have this all projects thing. Let's open this up. And don't need this, or this, and this. Okay, Alpha 3. So I'm going to continue with the GameBoy assembler, right? Which is more or less a rewrite from the old one, which was a Visual Studio project before. And I want to convert it into something that doesn't use the C runtime library and has this project structure where I just use bat files and all this kind of stuff. So because I do not like Visual Studio and I do not like maintaining projects in Visual Studio with the solution files and all that kind of nonsense. It just annoys me. So I more or less will be copying this code, but I thought like just copying this code and making it work without the C runtime is a bit boring, right? I also do not like this code very much because it was hacked out before I knew how to do a few things. So I figured, hey, so more or less a rewrite would be nice as well. So I'm going to be doing that. So what have we done? Last stream. Let me refresh my mind. Let's see the... Nope. Projects. GB assembler. Let's go to Alpha 3, right? Build it, run it. Okay, so what we've done is we fixed the column thing. As you remember, there were some things that were overflowing, which was not pretty nice. We kind of also tied up error handling. So we now have a global error list where we can just push errors onto, and it will then print them out all at the end of the file. And then I added this little thing here that says, how long it actually took to not compile, but like assemble your assembly file, right? How long it took to parse and... Oh, I apologize. Hay fever season is on. And then how many lines and across how many files have been processed within that time, right? So that is pretty cool so far. Thank you. So we actually have the tokenizer working now. So in the to-dos, let's see what we have on next. So think about token buffers, right? Okay, this is how do I want to put tokens then into the parser, essentially. Do I need like a token buffer, or do I do something similar that I've done on the source files where I can just look at the current position and fetch the token or the cone point that's currently there. And then if I use it, just swallow it. Basically a peak and then an advance. You can think of it that way. Which is actually what I think I will be doing for the tokens as well, because it's nice to have the same patterns throughout. Then implement symbols table and hash map with arenas, right? So that will be something to do, and implement basic command line options, because at the moment we're just looking at the hard-coded file that's right here in data, and it's the program gbasm, right? This is an actual working program, so this is a hello world program. And my old assembler could actually, so the Visual Studio version could already take this hello world and actually spit out a fully functional working Game Boy ROM that you could load in your emulator and run. So we're trying to get the same thing working here. So what will I be doing today? I think... So thinking about token buffers and how to advance tokens and stuff, I don't know. Maybe I will do that a bit later, because there is some other tokens I want to add anyways. So for example, hexadecimal and binary and stuff like that, they don't fully parse the numbers at the moment, and I would like to do that already in the tokenizer, I think. Wait, this is the token code point. Here, those are the tokens. I was wondering, like, what? Those are not the right tokens. Oh, sorry, I should probably increase the font size, right? What should we choose? 18? That's a bit big, isn't it? I think this is fine. Is that readable to anyone? A 16. Should be fine. As I said, I'm a bit late, so I will be munching on my cornflakes. Sorry. Excellent. Should be good. It's here. Not surprising, if I code off stream, I don't use the same font size as I do on stream, right? Because this is freaking huge. I like to have as much information on the screen as possible. So yeah, I think I will think about this a little bit later, as I said, because I need more tokens as well. It's definitely something I need to do before I go into parsing, but what I also need before I go into copying the parsing stuff is implementing the symbols table or hash table, right? And we already have an implementation here, but it is a bit, yeah, it's not great. I don't quite like it, so this is the hash table right here. So I want to translate that over. I mean, I will be using the same hash function here, djb2. If you wonder where this is from, there's this CSE yorku.ca and then tilde oz hash HTML, right? Which lists a few hash functions. djb2 is listed as here, which is quite nice. So I will be using this one. It's fairly simple, straightforward. And apparently it has a really good, it works best for different sets of keys and table sizes and that kind of stuff. So it has a really nice distribution apparently. So we'll be trying to use that. So let me just think about how to approach this. So the old table had just like a string with a name, right? Then a hash, and then a void star, a void pointer to some kind of data, which could be anything, right? The hash table itself had a fixed size. So once this was full, you could no longer parse. And I want to obviously get rid of that as well. Collisions were handled by just putting the item into the next available slot. So there was no linked lists involved or anything like that. With the arena approach, I probably have to go with a linked list approach, which is fine. I mean, just occupying the next slot actually works a little bit better on modern CPUs because, you know, the way caching works and how it just fetches the next item in memory. And if they're all contiguous in memory, then lookup is fairly fast, as opposed to like a linked list where you have to jump around through different memory locations and then invalidate your cache. But I mean, you know, I don't think I really care about this for the assembler. We'll see how it works out, right? You can always change that later. The growing strategy is not that important, or how you handle collisions, right? That is an implementation detail. So if that turns out to be really slow, we can always change that somehow. So yeah, so this one was a fixed size. The new hash table will also be a fixed size because, but because I'm using linked lists for collisions now, they can just live anywhere in memory. So the fixed bucket size is not necessarily a problem. Obviously, it will become slower as you fill up the table. With the approach that I have here, I don't even know what it's called. Is it open addressing or something like that? I don't know. I'm not familiar with the terminology too much. Don't really care, to be honest. But like, if you use the collision handling where you just occupy the next slot and you still want kind of be able to increase the bucket sizes or whatever, essentially what you would then have to do once the whole array of items is full, you would have to create a new one, right, with a larger size, and then basically rehash all the items and put it in the new table, and then get rid of the old one. I think that's even something I did for this hash table in the beginning of the stream until I realized, hey, why not just have a fixed size? But yeah, now that I think about it, a fixed size is probably not that nice because, like, who am I to tell the user they're only allowed to have this many, I don't know, symbols in their program, right? It's like, I don't know what people are going to do with this. So, I mean, let's be honest, it's probably just me going to be using it, but hey, you never know, right? I don't know what I will be doing in the future, if this should grow or not. Yeah. Soggy cereals are not great. I let them sit in the milk for a bit too long. So another thing which I was playing around with, which I was just learning yesterday about, is this Wagner-Fisher algorithm of like finding the least amount of edits needed between two given strings, right? And I thought it would be a really cool idea if, you know, the assembler, if you have a symbol that you don't know, or like a keyword that is unknown, right? Usually programs will just spit out an error saying, hey, this keyword is not known, or unknown symbol, right? Like, I don't know what this is. And I thought, wouldn't it be cool if we just had a dictionary with all the symbols that the program knows at the moment and just trying to figure out what the user tried to type? So then the error message could then say something like, hey, this is an unknown symbol, but did you mean to type this one? You know, because it's fairly close to what I know here. I thought that would be like a nice addition. I'm not sure if I will get to it today, but the algorithm itself is like fairly simple. Like it's there's a really good wiki page on this as well, actually. There you go, Wagner Fisher. Basically, how it works is like you have this matrix between two different strings, so string A and B, right? And then those are the basically these numbers here are the needed steps to edit the string to get to your destination, right? So this is an empty string. If you have a string that's just S, you need one delete to get to an empty string, right? And then for Saturday, if you have that word, you need 8 deletes to get to an empty string, right? And then with this matrix, you can sort of calculate how many edits you need to get from this to this string, right? So for example, to get from Saturday to S, you would need 7 edits, right? Or to get from Saturday to Sunday, you need 3 edits, right? So you need to change a few letters or delete something or like exchange something. So that's fairly cool. Just look up the Wagner-Fisher algorithm if you're interested in that, or the Levenstein distance, which Wagner-Fisher is like based on, basically. Yeah, this one explains it in great detail as well. Though for some reason they use like Haskell code instead of like pseudocode, but yeah, whatever. So yeah, so basically what that means for the new hash map is I not only want a hash map with all the symbols in there, I also want some kind of dictionary which just contains the string. Ideally, those should be, you know, in contiguous memory, so we can iterate quite fast over them because we have to go through every single string within that dictionary. And yeah, I'm already thinking of ways of how I could speed that up so I don't have to go through that whole dictionary. But basically what it means, we need the hash map, but also what we need is kind of basically a dynamic array, right, somewhere in memory that we can grow, where we just put the raw strings in there. That will be our dictionary. Okay, but let's just start with the hash map, right? So let's just put this in base and think about what the hash map would look like. I have no idea. Probably similar to what I already did, but I kind of want to figure out a different way of doing things. We'll find it out, right? So define GB assembler, and this will be hash.h, hashmap.h. Yeah. Sorry, not define. If not defined, then we want to define it, and if, right? And then we save this as hashmap.h, and then we'll probably have hashmap.h, we'll have hashmap.c, and we include that in our program as well. Probably after string, right? Include base hashmap.c. Okay. So this will be our hash map. Now, what does our hash map need? It needs an arena. Right. This arena is for adding new items. So every item that we add needs to go somewhere in memory, right? So we can probably just use the default memory arena of the program right here. Thinking about this for the dictionary itself, so where we put all the strings, that probably needs a whole different arena, but that is not the job of the hash map anyways, right? We'll have to maintain that dictionary outside of the hash map. I don't want to couple those together. Because like if you decide to not have this dictionary to, you know, find like the closest symbol name to what the user might have thought they wanted, right? Yeah, you don't want to couple those dependencies together. So, okay, so we have an hash map, we have an arena where we will put in all the new items. And then we'll probably have... Well, let's do the nodes, right? So type def struct hash map entry. What did my old entry have? Okay, I didn't even care about the entry here, right? Because, like I said, it was not linked list based, so I just made it a void star, so I could put in anything that I wanted, which, yeah, not ideal. I mean, no, that is actually right. What am I talking about? Where's the hash table? Oh, I used the buffer. Okay, so I had this weird dynamic buffer struct here. Well, it's not necessarily dynamic buffer. It could also describe a static buffer, right? But it was basically just a buffer that held a base pointer to some kind of memory, specified what the size of a single item in this space is, and then the overall capacity and how many items are in that buffer. If it would be static, well, do I even have... Yes, there you see, I had this resize thing here, allocated on the heap. Fantastic. Okay, so the hash map was just a type def for a buffer. Neat. Not sure I will be doing that, given that I don't have a buffer struct at this moment, right? Okay, but I mean that is right. So what we need is a string, right? So let's call it name. No, let's call it key, right? Let's be correct about this. So we have a key, and then we have a U32 for the hash. That is like the basic information that we need. And then, well, a hash map entry then has an item that it can store, right? So that would definitely be something like this, like data, which is fine. But now for resolving collisions, what we also need is pointing to the next item in the list, right? So if we have something with the same hash, but a different key, we want to point to hash map entry next, right? And these entries are the things that then will be stored in memory, in the memory arena. Actually, I don't need to carry around the hash for everything, because like every entry has the same hash, so the hash could be something in the bucket, right? So I can now make the bucket a different, completely different type. So let's do that. Hash map bucket, right? By the way, I'm just winging it. This might change. I have not thought about it too much beforehand, so we'll see where this goes, right? So U32 hash. So this hash map bucket, okay, right, that is fine. And then probably what we want to store in there is a hash map entry, right? And if this is null, we know this bucket is unoccupied, so no collision will happen, so we can just fill out the entry. If the entry is not null, and there's an actual entry in there, hey Mo2, thanks for the follow. If the entry is actually not empty, then we can just look up in the entry and traverse the tree, right? Traverse the linked list through the next items until we discover one that's actually empty, and then we just put it in there. Well, there's a bit more involved, right? We need to compare all the strings and see if we actually have that item within that list. So this is what makes it a little bit slow, right? I mean, I say a little bit slow. It's not slower than what I did before with... Well, it kind of is, but not really. So in before, when I just occupied the next slot within the array, I still had to compare the strings and everything. The advantage of that one was just everything was in contiguous memory, so that was pretty nice. But this way of doing it with a linked list just makes it easier, even though it is slightly slower on modern machines, but it's all right. We can deal with that. Okay, so, and then we have a bucket, I suppose. Well, we have a bunch of buckets, right? So, buckets. Although that would be the base bucket. Should I just call it base? Right, and then we have a U64, which will be capacity, right? So how many buckets do we have? I don't know. Right, and then this is the base pointer of the buckets, and if we want to get to bucket so and so, we just index to it. Okay. Let me think about this for a few seconds, while I also eat my incredibly soggy cereal. I'm sorry. I'll try to not do it too much on camera. Hang on. By the way, as a public service announcement, it is the 1st of April today, so be wary on the web. Do not trust anything you read or see, except, of course, me. Like, you know, I'm not... I'll definitely be staying away from the news sites today, honestly. Okay, right. So those are the basic data structures. I mean, they kind of look okay to me. So what we probably want to now is have some functions, right? We want something that creates a hash map for us, right? So hash map t. Do I already have like a pattern of what I call these things? This was init global error list. Open source file to do that. How did I name? I just said new memory arena. Yeah, let's follow that pattern. So new hash map, right? And what we want to pass in is the memory arena that we want. So that arena will be used to store the array of buckets in there. And it will also be used as the arena for new items itself. So after all the buckets, all the entries will be stored in there. Right, and since this is our global arena, there will be lots of other stuff going on as well. We just fill up everything. But yeah. And then probably what we want is to be able to specify a bucket size, right? So how many buckets do we want? Let's name it capacity as well, right? Let's not expose the name buckets to the outside, to the caller. I mean, this is C. We expose everything, right? Whatever. Sorry, this needs to be a pointer. My brain is slowly firing up. And then for Memory Arena itself, you have to, excuse me, I always have to look up my own names. I don't have them fully ingrained yet, which is a bit annoying, right? Oh, I have this Get Memory Arena type, which is nice. But I want to allocate a lot of things, actually. Okay, so what we're going to do is, so first, arena, right? So we're getting a buffer out of the arena, and the size of that buffer, let me do it this way, buffer size will be capacity times, right, times the hash map bucket, right, because we want the amount of buckets in there, times size of hash map. No, not times. Jeez. Plus. Ooh. That would have been a bit big. No. Okay. So yeah, we're getting the capacity for, you know, however many buckets we want. That means we have to times it by the size of the bucket itself, right? Because every bucket like needs a hash and the hash map entry, and the hash map entry needs like these kind of things. So it needs a bit of memory. And then we have the hash map itself, which we also want to store in the memory arena buffer, right? Okay. Buffer size. And then what we can say is hash map t map, right? Let's be nice and cast. If map is 0, let's do it this way. If map is not 0, then we do like specific things. Otherwise, otherwise we just return the null, which is fine, right? Because allocation failed. We just return null. I don't want to have any error handling in the hash map thing itself, because that is not the responsibility of the hash map, right? That is the responsibility of the caller. Okay, we want a few asserts. Capacity should be bigger than null. I am wondering, do I have... I have align power of 2, and I think I should do that with... No, that... It should be a power of 2, though. So let's make that. So let's also make sure that capacity is a power of 2. Right. Okay, if the hash map is not null, then we have a valid hash map on our hands, right? So what we do is we assign the arena to it, and we assign the capacity to it, and well, the base, right, is just 0. No. Ah. The base is not 0. This is what I need to do, right? So this base now needs to point to the memory after the hash map. So what I need to do is map base, because this is where the first item begins, right? I'm wondering if I should align those as well. And I kind of want macros for the size of... Okay. Did I call this type size or... Oh, I just called it header size like this. You see, in the memory arenas, I have an alignment that I can specify. By default, I think it's like 8 byte. Yeah, 8 bytes or something. I wonder if I should do that for the buckets as well, but I'll think about this later. To do add alignments for the buckets. And then the base, oh, hash map header size is fine. And this will be hash map t, right? Okay, this is plus hash map header size. Hash map bucket size. Hash map bucket t. Hash map entry size. Nope. Okay. Okay, and so the base will actually just be pointing at map. I mean, just +1, right? Because this is a hash map. So it'll actually jump forward by the size of that thing. Yeah. We can make sure this is correct in the debugger in a moment. Okay, let's leave the to-do here. Actually, let's maybe... Okay, now I need to know if my arena is actually zeroing memory or not, because I'm not sure. Okay, virtual alloc. Let's check. Win32 virtual alloc. The function also guarantees that when the caller later initially accesses the memory, the contents will be 0. Well, that sounds good, doesn't it? Hey, what's up? I might have to let my dog out of the room. Hang on a second. 1 second. Fine, go. See you later. All right. I should turn off alarms. It is a rough morning today. Nope, I actually should leave the alarm on for 1 hour warning. Let's see. There we go. Now, okay, now I'm curious though. Like, is there a way to not have it 0? Like, what if I will just... Like, what if I want to... like, allocate quickly, and I do not care whether the contents are 0 or not? Probably doesn't allow that, right? Large pages, no. No, of course. You want it to be 0. Otherwise, data from other programs will flood into your program, right? The reason why heap alloc and stuff like that is not 0 is because, well, it must just reuse memory that you've already used from within that process, right? Memory allocated by this function is automatically initialized to 0. Okay, cool. So all I wanted to know is like whether I have to go through each and every single bucket and try to make sure that everything is set to 0, so the entry pointer and stuff like that. But apparently virtual alloc will take care of that. So cool. So no zeroing necessary. So this is pretty much all we need to have a new hash map. That's it. Right. Let's move this into the C function. Into the C file. Oh, I put it all into the C file. Okay, this is definitely wrong. This needs to go into the header. Right. And I also need this declaration here. Bam. Okay, so this is our new hash map. And then we can on program run, before we open the, yeah. So let's say hash map t. No, let's call it symbols, right? Because this is our symbols table. New hash map. We're using the global arena. And then we need a capacity. Let's just do 1,024 buckets. That's huge. Okay, so if symbols is null, then I have this write last Windows error and exit, right? Which is pretty much what I do here. Okay, maybe I should allocate the hash map like within the main function like here, right? Because this is like the basic setup before we run the program. I'll see where this takes me. For now, I just want to look at the symbols, right? So let's do that. So let's do, build. Jesus, build. Huh? Oh, right. This needs to be a hash map bucket. Okay. Let's debug this. Program run. So let's go here. One second. Give me a minute. sorry. I thought the dog might want to come back into the room, but apparently not. Okay, so, right, this is all stuff from yesterday. I can zoom in a little bit. Hope that helps. Yeah, should be fine. Okay, so here we have our arena, right? We are currently in position 5, 6, right? Because we already have a bunch of stuff allocated in there. So let's go over this. Now we are in position 9, 6. That seems a bit too low. Where's Symbols? Why is Symbols not here? Well, Symbols is null. Huh? Okay, hang on. What? What did I do? Okay, let's go to new hash map. No, actually, right, let's just do it this way. F5, and then we step into this, right? Solid. Am I tripping right now? Build. Oh. I had a build error and I didn't realize. Oh, man. Yeah, of course. This is U32 exit code. Right. Build. Okay. Now, step into F5. Cool. Okay. You know what? Let's step in anyways and see what actually is happening. Right. So the asserts pass. Yeah, as expected. So, capacity is 1024 buckets, right? And then hash map times the hash map bucket size plus the hash map header size. And that comes to 16,408, right? And we're trying to allocate that right, which works. So the position in the arena now advanced by quite a bit. And then we have our map. So our map is not null, which is cool. Okay, so the address of our map, right, is this. Now, if we go to plus hash map header size. No, that won't work. Size of hash map t. Right. Damn it. Okay, size of map. And we want this as hex. Okay, so this should be the address for the first bucket, right? So we're setting the hash map capacity, we have the hash map arena, right? And then we have the hash map bucket, which that looks correct. Cool. And here we can also see that every hash map also has a bit of padding. 4-byte padding, it seems. Seems like a lot. And we have the entry, right? Which doesn't seem to have any padding. Interesting. I wonder, what if I switch those around, right? Then the padding is gone. Cool. I really like this debugger, man. I really do. It's great. I'm still learning it. I'm still not like fully, well versed in this, but it's just great. Honestly, I can just recommend it to anyone really. Do I actually need the disassembly? Can I just put this here? Right. But why? Weird. That's weirdly structured. Why does it not, why does it keep this thing here? Why is this like a fixed layout? I also should mention this debugger is still in alpha. I have to close the panel. Control Shift P. Okay. It's a bit weird, but I do not need to see the disassembly all the time, right? It might just be useful sometimes, so I just rather have it in the same way as the source code right here. Okay. Cool. Okay, so we have a basic hash map. So now we can start writing functions, right, that actually interact with the hash map. So what do we need? So I had this hash table insert here, right, before. That either returns success or exists. or it reported that the hash map was full. So we no longer need hash map is full, right? But success and exists, right? So why would I want to be... Why do I want to care whether an item exists already or not? Well, this is if we want to define a new symbol, right? And we're going to pop it in there. We want to probably throw an error if it already exists. But I mean, that is just success or failure, right? If we can't add it, then it might be because it already exists or not. No, if we can't add it, then it is only because it's already existing, right? We can always add something. Well, there is one other reason why we can't add something, and that is if the arena actually runs out of memory, right? But in that instance, like, all hell breaks loose anyways. But maybe I do need to distinguish between those two moments. And then for some reason I passed the slots, so the bucket slot, back out to the caller. Now why is that? Why did I do that? Because I wanted to attach the data to the entry, but that can be done easier than that? Like what? I seem to have been overcomplicating a few things here. Let's see, what's the other instance? So we have the index. Yeah, I really just use it to get the entry and then attach the data to it. Like, that can be done within the function. I don't know why I did that. Right, okay, so in this instance, it kind of makes sense, because if it already existed, then I wanted to get the entry. To then report, hey, you already existed, mate. Okay, so the insert, actually we do not want to return like the bucket, right? But we also really don't want to return the hash map entry itself. We really just want the data. And to figure out whether the data exists or not, we can just check if the pointers are the same, right? Because if we're trying to add new data, we presumably, you know, put it on the heap or on the arena or whatever, and then it has a new address, right? And then we can just compare addresses. And if the addresses are different, then this item already existed, and we just return the item that already existed. So I do not need this whole index nonsense that I did right here. Like, yeah. Okay. So we have a void pointer. get hash map entry, right? What do we want? Entry based on the key. Do I have different... sorry, that was for insert. Yeah, we should do insert first, right? Insert... hash map insert. Wait, I even passed the data in here. What? But then why did... Okay, now I'm thoroughly confused what I was thinking. Oh. I was deferring the attachment of data. I first wanted to make sure that the entry does not exist. And only if it didn't exist and I could actually add it, then I was starting the parsing process to add it to the symbols table. Because in my mind I was thinking, well, if it already exists, I do not need to do all this work, right? That's why the index. So I didn't have to go through the whole hash map itself again to just attach data. But then... Okay, so maybe I should return the entry? No, but then you kind of have next in there, which is not great either. I could trick a little bit and make this another struct. So I can return like a hash map entry data struct, which basically just holds one pointer. But that means I return the hash map data struct here, and then I can just change the pointer to data. Let's try that. I mean, what I could do is like... Nah, I'm not sure the length is actually needed. But let's just do data. Data. So then here on hashmap insert, what we're getting is the hashmap entry data, right? We can still pass in the item. let's call this item. Hash map entry item. Quite a mouthful, isn't it? Well, just hash map item. Yeah. Right, bucket entry item. And this is the item data. Yeah, that makes a bit more sense. And then instead of just void star data, we're gonna have the hash map item, right? Okay. Oh, and I of course also need the hash map I want to add this to. Map. Let's just call this value. How about that? Insert value, new hash map insert value. Yeah, okay. Okay, we want an assert for the map. The map should not be null. Then key base should not be null. And key length should not be null. And you know what? Data can be null. We don't care what the data is, right? Sorry, the value. Right, okay, so now this is where the whole hashing comes in and the hashing methods. So let's just copy this hash method. I'm just going to reuse that one, right? So U32. Compute hash. Oh, look, I tried to be fancy with the register thing here, but let's just remove that for now. Okay, so we have name, size t will be U64, right? That is the length. Name plus length. It can be nice and put an assert in there, even though we're asserting that beforehand, but name should not be null and length should not be null, right? Again, these asserts are only useful during debugging. For the release mode, they just will be removed. Okay. So we want the hash of our key. Compute hash. We have key.base and key.length. Right. I did this here already as well. Then we have the slot, or rather, let's name it bucket, right? We want to put it into a specific bucket. And that will be the hash with modulo based on map capacity. right? There we go, the same thing. Okay, this will be a bit different now, given that I use the linked list method now instead of just doing the next slot. So what I did in the old one is I had this loop which started at the suggested slot, right? But if this slot was already occupied, I just went over to the next slot and checked if it was free or not, right? And I did that until the end of the array. But then, you know, if all of them, let's say you're on the second to last item, which is occupied, then the last item is occupied, then where do you put it? Well, you start at the beginning from the list again. This is why it went here, where it actually went from the beginning of the bucket list to find the next slot there. Now we don't longer have to do this. We just look at the slot, and if it is occupied, well, we just look at the next item, and the next, and the next, and the next, right, and so forth. So but the first thing what you need to do is create, so the buckets, the buckets are fixed, right? So where the entry can be null or not. So what I need to create is a new hash map entry. Right? And put that somewhere in memory. So that is the first step. So really what we want is get memory arena buffer, and I'm just curious, how come the hash map entry has a reference to next? Is it so that you can also enumerate the hash map as kind of a linked list? No. This is purely to avoid collisions. So let's say you have two items that for some reason generate the next hash. Then what do, right? Like different strings, same hash. You can't put them in the same bucket, right? So that is what is typically called a collision. And then you kind of want to resolve the collision, and there's many different ways of doing it. You either just go to the next slot, like to the next bucket, and fill it up with your item. Or, as in this case, you attach it as a sort of linked list, where you just say, okay, here's the collision item, just put it next in the list, right? And then when you actually look for that item, you go to the bucket for the hash, and then you basically compare the string, and you say like, okay, is this the actual item? Nope. Okay, go to the next one. Is this the one? Or is this the one? Is this the one? Right. So that's why. And again, you can either do this via linked lists, or you can just have an array, you know, where you calculate which slot you put it in, and if it's full, you can do the next slot, or you can do some other algorithms which use like a specific kind of offset or whatever, or you calculate based on how full the hash map is to kind of figure out where to put it next. So there's all kinds of fancy ways of doing it. Now, if you do this as an array and just use the next slot, or whatever algorithm you have to determine on which slot to put it, that usually has the benefit on modern CPUs that is like really fast to iterate because of like how it puts things in the cache, right? So the next slot will most likely already be in cache, so the CPU has really fast access to it. While with the linked list here, the next item might just be God knows where in memory, right? So it might take a little bit longer to actually fetch it because it might be outside of the cache boundary. But as with everything in programming, with trade-offs, right? If you do this as a linked list, it has the advantage that you do not have to worry about growing your sort of hash map array at some point, because at some point everything will be full, right? So what if your array is full? Like the hash map is full essentially. With the next slot approach, you would then have to allocate more memory, right? Copy the items over, put them in new slots and all this kind of stuff, and then carry on. While with a linked list, you never need to increase your bucket sizes. You just leave them in a fixed size, and you just, continue shoving in somewhere in memory and just point to them. So yeah, whichever is better or not, I mean, it probably depends on what your program needs to be doing, and you probably should profile 2 different implementations and see how they perform and all this kind of stuff. I'm just going with this approach because it kind of feels nice and easy to think about with my memory arenas that I use as the allocators. So yeah, just different approaches. Okay, so get memory arena buffer. I had this little macro recently. Get memory arena type. Yeah, this is the one. So I can just say map arena. And I want to specify the type that it should return to me. And in this instance, what we want, right, is a hash map entry. No, just hash map entry, like so. And then we have hash map entry. Okay. Now, if entry is 0, then I have to think about what to do. What do I do here, right? But let's just pretend it worked. And then we figure it out from there. So entry, what does entry have? Why are you opening it on this side? Hey, thanks for the follow. It always opens the head on the wrong side. Whatever. I just wanted to quickly check what entry actually has. So it has the key, right? Okay, cool. It has next, right? And it has the item in itself. And the item in itself is just basically the value. That's all there is to an entry. Okay, so the key is just the key. Right, I copy just that. And when I say copy, all it copies is the base address of the string and the length of the string. So 2 items, really. Next is 0, right? We don't have anything to point into. Now, I know I said that like virtual alloc already has everything zeroed out, so I potentially do not need to do that. But keep in mind, this is an arena. This block of memory that I'm getting here might have already been used somewhere else, right? So I should definitely specify this as 0. Thinking about this, probably should have done it here. Now, in the way I allocate this is actually not possible that it might have been used before, but yeah, I probably should think about this. To do, make sure buckets are 0, right? Okay, and then we have the value, and the value is just, well, the value pointer, right? We just need to assign it. And that is our entry. Okay, now we can traverse, look up the bucket, right? So the current hash map entry that is within that bucket. So we need to get the bucket. which is this little fella right here, right? So we need a hash map bucket, and right. I should have named this slots. And this is the bucket. Not entry, what am I doing? So we want the map, we want the base, right? And then plus slot. That will be our buckets. Actually, let's make the syntax a bit nicer. I kind of like this better. And then bucket has the... Okay, first we figure out whether there is an entry or not, right? So bucket entry... if there is no entry, we just add it. And then what we can do is just say entry is entry, right? And then bucket hash will be the hash. Now, if there are entries in there, we need to now traverse all the next items to figure out to basically add it to the end of it, right? I'm wondering, do I really... I don't know if I want to store the hash in the bucket. Because, like, depending on the sizes and the sizes of the hash, right, I can have multiple hashes occupying the same bucket, so that didn't make any sense. So I really need to do this. Right, so really we can move this up, and then here on hash we can just attach this one and then say entry hash. Actually, maybe I do not even need to do that, but we'll see. Okay, hash map entry current equals bucket entry. Right, and then while current next So we create the current entry of the bucket. We check if while next is not null, then we set current to current next. Right? And then we check again if that one has an item, and so on and so on and so on. And in the end, we just assign it. Now, there's a few more checks that we need to do to figure out whether the item is already in there or not, right? So we can do that. But let's just... so we need to return the hashmap item, so all we need to return is entry item, right? That's it. Well, we need to return, sorry, the address of entry item. Okay, so that is very basic, but we need to do a few more things. So we kind of just look for the next empty slot. We also want to make sure that this item is not in there at all, right? So how do I do that? So what do I need to check? I need to check, yeah, let's make it to do. I need to check entry hash, entry string, and I do not need to check the value. That is part of the caller, right? We just care about those things. Okay, so basically if current hash equals entry hash, and for string equality, I have a function right here, is string equal. Current key and entry key. So if both of these things are equal, then entry already exists, right? Then we already have a key, like an entry with the exact same key and hash in here. If only the hash is equal, then that is a collision, right? So we can just continue. But if we actually found that entry, then what we want to do is actually return this entry instead, right? So really, so return the address of current item. right? And we need to do this for every single thing. So do, oh, come on. While current next is not, no. Trying to think how to combine this into a nice loop, but my brain is failing me at the moment. Get some water. Let's just make this without the loop at the moment. So, okay. How would I do this? So we get the current entry, we compare them. If they are equal, we return this one, right? Then if current next is not null, I have not used linked lists much. Let's do. You never had to write a hash map yourself before? Yeah. I mean, you rarely have to these days, right? With libraries and everything available for you. I'm just trying to make my life extra hard. I'm not even using the C runtime library at all in this project, so I basically want to do almost everything myself. As a learning experience, really. Because I want to become a better coder. Yeah, it is a fun challenge. Like throughout all my software career, I only worked with like high-level abstractions and libraries and all this kind of stuff. I never had to worry about implementing my own hash map either. Like maybe way back in school, although I didn't even think we did hash maps. That's like really basic what we did, but you know. Maybe if you go to university, then you have to deal with these kind of things as a course at some point. But yeah. I'm not sure how to do this. Maybe this way. Maybe that works. I don't like this early return here. Maybe we do not even need that branch. Hang on. That's... Whoa. Wrong key. Yeah, I need to do an early check here. Because this is just a bucket, right? Okay, I do need this branch. I mean, I can do it this way maybe, and then if current is null in this instance, then I can just say bucket entry is entry. Otherwise, right? Yeah, go back to the do while. Oh. Sorry, this is slightly messy because I'm trying to figure out how to do this nicely. Then if we have all of that, we want to return... What if we just break out of here? Right. So we have a previous and we have a current. The current will be the bucket entry. If current is null at this stage, we know there's absolutely nothing in there. So we can just say bucket entry is the entry, and then we set current to entry here, and then in the end we return the address of the current item, right? Then if we do have something in there, then we need to check. So if in the bucket the first entry actually is something valid, then we check the hash and whether the string are equal. And if they're equal, we're gonna break out of this loop. No, that won't work, will it? I wanted to like avoid early returns. I'm just gonna have to do it, whatever. Okay. Right. Fine, 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 fine. Whoops. Okay, then I don't need this, right? We can actually say, I mean, this is fine here. Why not? So if the first entry has something, then we can do this. Okay, fine. Yeah, I need to do something special in this instance anyway, I just realized. Because I need to give up the memory that I've already allocated up here for this entry, right? Because we no longer need it. If there's a need to compare current hash with the entry hash. I mean, the way I have to see this is like an early termination, right? Instead of comparing the string throughout, you just want to make sure that the hash is actually equal before. Like comparing two integers is fairly fast, but comparing two strings takes slightly longer, right? So you do not just want to always compare the string. You want to compare the hash first, so you can terminate early to be like, okay, this is definitely not the same. I think this is okay. The only thing I need to do here is give back memory, right? So, and I have two ways of doing this. Basically, before you allocate anything on the arena, you can get the position the arena is currently in, right? So you can get memory arena position, right? For the map arena, right? So this is the amount of memory allocated before we do this one. Then we allocate the internal memory map arena position, you know, increases, obviously, because we're putting an entry onto it. But if the entry already exists, we can get rid of that entry. And so we just freeing up that portion that we kind of blocked out for something else to use later. And the way you can do that is just by rewinding to the old position, right? So you can say position, right? So rewind memory arena to position. Bam. Let's say this position is like 1024 bytes before this, right? Afterwards, the position in the memory arena is like, I don't know, 1030 or whatever. Yeah, it's probably not correct, but whatever. If you then no longer need that entry, you just give up the portion of that buffer and you rewind back to position 1024, right? And the only reason for doing that is if the entry already exists. Everything else, we just want to hold on to that buffer to store that entry into, right? I'm still not sure if I'm quite happy with this code, but let's leave it like that. That's fine. Actually, I mean, I could do... to avoid an early return, right? I could do something like this. And then... whatever. It's not really a nice way of doing it, but... I'll revisit this later. I spent way too much time on it already anyways. Okay, so but what I want to do if we cannot get any memory, well, let's just return null for now, right? Then we knew something went wrong. Otherwise, we will always get a valid entry. And then the caller can decide what to do if this is null. Okay, we are setting next to 0 here. We're setting the value. That is correct. I'm just trying to get through it one more time, right? We have the slots. With the slot, we can get the bucket. With the bucket, we can get the entry. If the entry is not there, add the entry. If there is an entry, make sure it has the same hash and the same string. If it does, rewind the memory arena and return that current item that is on that position, because we already have the same key. Otherwise, set previous to current, and then set current to current next. Make sure current is not null. If it is null, we set previous next to the entry, and then return the entry item. Okay. Kind of makes sense. Now we need a get, right? A get function will look slightly similar. So we have hash map item t, hash map get value, hash map t map, and all what we want to get is based on the string, right? So something like this. Whoa, why did I copy that? Right, so here we can make a few asserts. Map should not be null. Key base should not be null. and key length should not be null. No, if the hash collides, then you make sure that the string is equal. Okay, so let's assume you have a key that is foo, right? And that will produce hash, I don't know, 42, right? And then you have a key that is bar, and that will also produce a hash that's 42, right? Then to make sure that those actually are the same items, you would first compare the hash, right? 42 equals 42, that is true. But then foo does not equal bar. So you know it's not the same item. So you just look up the next one, right? Until you find the same hash again, and then compare the strings to make sure that they're equal, right? It can also happen that another key is in there, you know, that has a different hash. Let's say, I don't know, XXX, triple X, resolves to hash 52 or whatever, but for some reason it ends up in the same bucket because we need to wrap around, right? Because like the hash can be a U32, while our buckets, we only have 1,042 buckets, which is quite a lot anyways. So it might happen that this item ends up in the same thing here, but then we already know those can no longer be the same item because the hash is not equal, right? So we can just look up the next item in the list again. So that's kind of how you have to think about it. Does that help? Okay, cool. Okay, now to get an item out of the list, we luckily don't have to play around with memory arenas and all this kind of stuff, right? So all we have to do is find the slot and the bucket of the key that we pass into, right? Well, we also need to calculate the hash, so we need this one, right? But that will be U64 hash. We compute the hash of the key. We get the slot. And with that, we get the current bucket we're looking into. And then all we need to do is well, get the first entry, right, from that bucket. And if, while current is not null, we're just going to look up the next. So while current is not null, because the entry can be empty, right? So we calculated the hash that's not in the list. So current in that instance, bucket entry would be empty, right? Would be null. In which case we just return null because, yeah, actually, let's do that. Right. So the item is not in. But if there is something in place, we need to do the same thing. We need to like compare. We're comparing the hash and we're comparing the keys, right? But here this is just going to be key, so it's current key. Oh, and this is not entry hash. This will be just hash, right? And if those two things are equal, then we have found our item, and then we just return the address of the item, right? This is it. We found our entry. Otherwise, we need to look to the next one. So what we can do is current next. And then we go to the loop again, right? And if next happens to be 0, then there is no next item, so we just return null because we have not found that item in our list. And that's it. That was almost way too easy. Okay. I spent just way too long on this one. See, in this way with linked lists, I like the code much more. Well, except this part is kind of fugly, but it's like 90 lines or whatever, right? And now if you compare this with the one that I had before, it's like 100 and what? 63, right? Roughly. I mean, there was just... What I never really liked was this double iteration here where I go, you know, from the bucket up to the end to the array and then had to go at the top of the array all the way to the bucket again just to find an item. And it was just kind of very, very weird to write. Yeah, didn't like it very much. But okay, cool. So we have a hash map. Nice. We can test that one. Let's say, okay, so what do we actually, do we have a capacity? Oh, but we could also add now, because maybe we want to know how many symbols are actually stored within this hash map, right? So instead of just having capacity, what we could also have is count. So the item count, which can be a lot. Actually, capacity, okay. Hey, Red Zone. The term capacity maybe doesn't make much sense. Maybe I should rename it to buckets. Right? I mean, the capacity sort of makes sense here, but it's kind of confusing because you think that's the capacity of how many items you can store, but that's not quite true, right? Well, this is the capacity of the hash map, but maybe we can just name this entry count then, just to be a bit more verbose, I suppose. So let's add that. So map, whoops, entry count is 0, right? And then whenever we go here, we can actually say map entry count plus plus, right? Because this is when we actually add an entry. Only this one we don't. And then we can be cheeky and have an early check if map entry count is null, return null, right? Because, yeah, no reason to look into it. Okay, let's use it. Insert, no, hash map insert value, right? Then we have symbols. What do we want to add? Let's add foo, right? And we want a value of, well, let's just add this value, right? What we're getting back is a hash map item, right? Then we can add another value, bar, right? We can have value 2. Let's do 666. And then we want to find those, right? Let's say hash map get value, right? So symbols, and we want to find foo, right? And then we want to find bar, and then we want to find something that is not there. Yo, right? And here actually we also want item, hash map, insert value, and let's try and insert bar a second time with a different value this time, and it should fail, right? And then we can observe these in the debugger. Well, first we need to fix errors. Whoops. Red Zone. C was my first programming language. I have to do OOP for uni, but it's different way to solve problems. Did you find it hard to adapt to OOP? Funnily enough, C was not my first language. So my first language was actually Visual Basic. Although I didn't do that for too long. But then I went on to learn C++ in school later on, and then with a friend together working on a few things. So, and we kind of did OOP out of the box, right? And then throughout my whole career, I also only dealt with OOP because I was doing C#. So for me, it's actually the other way around. I did a ton of OOP programming. And I thought it was, like, for a long time, the de facto way of doing things, of writing nice code, professional code, and all this kind of stuff. Until I kind of, I always hated it a little bit, right? Thinking in terms of objects, and like, it's just, your code gets so convoluted, right? And I only recently, like a few years ago, came, to the realization that maybe object-oriented is not always the way to go. And I kind of figured it out based on stuff that I saw online that other people are doing, especially like in bigger game companies. There was, I think, something like a presentation from Insomniac Games or something, where he talked about the downsides of OOP, and kind of resonated with me. And then I looked a little bit more through all this kind of stuff, and this is how I ended up doing C again now. So not again, but doing C now. I use assembly for my current project, and I like being able to do a direct operation on my data and having global access to everything. It would be wrong to add complexity in walls, I think. Yeah, I agree. I'm writing this assembler here right now for the Game Boy because I do want to write, stuff for the Game Boy and learn how to write assembly for like a very simple CPU, right? Like, I wanted to start out with a sort of simpler CPU with very little instructions, because like trying to do assembly for x64 is like, what? Like, it put me off quite fast, and so I thought it would be nice to do that for a Game Boy. But instead of just using tools that are already available to me, I'm also really interested in how these tools work and how you can write tools like that yourself. That's why I started this whole assembler project. And in the meantime, also learning C, kind of again, right? I say again, even though I mostly programmed in C++, but there are some similarities, but I know they're different languages, but you get what I'm saying. Like, sometimes when I wrote C++ programs, I still used the C standard library in a way, right? Like printf and stuff like that. What kind of assembly are you writing? Like for what CPU? Bare metal x86 64 stuff. Nice. Yeah, I'm definitely not there yet. Like, I can read a few of those instructions, but like only the basic ones, like the jumping, and I kind of know how the offsets for the pointers are calculated a little bit, but that's about it. The most confusing x86 stuff is floating point operations and the diff instructions using rex and rdx implicitly. And it depends on the sign of the operation too. Right, the only thing I know about the diff instruction is that it's also producing you the result for the modulo. It's basically in one instruction, right? So that's all I know about it. The GameBoy CPU doesn't have floating points, so I'm kind of lucked out that one. But yeah, that's really cool stuff, though. Really nice. You're basically way ahead of where I want to go. I mean, JavaScript, it is what it is, right? I get why it's popular in a way, because it's like easy to get into, right? And I mean, I say that, but I guess it is easy to get into it. But yeah, it comes with its own challenges, right? So dealing with all the browser differences and all this kind of stuff, it's not that far different than trying to make your program run on different platforms, right? It's just on another level of abstraction, really. I'm not like a huge JavaScript hater or anything. I never really used it. I never really did web programming in that sense. Even the C# stuff I did was mostly backend stuff, server side stuff. So, yeah. Okay. Let's fix errors. So, whoa. No, that's not what I wanted. Nope, that's not either. Oh my. What did I do? There it is. That's what I wanted. Okay, I didn't need. Okay. I just tried to read what you wrote there. So those instructions I do understand, but I did not know about CQO to sign extend rags into. Okay. Well, that sounds like fun. looking forward to getting to those floating point instructions. I very much dislike working with JavaScript directly, though. I always use TypeScript. Yeah, I mean, I can neither speak for JavaScript nor TypeScript. Sorry. Wait, are all floating point instructions SIMD? I've only dabbled around with SIMD a little bit. I don't think I have a project here right now where I actually did try some stuff. Let's see. Here, I tried something with SSE2 and SSE4.1 and AVX2. But that's about it. But also from within C, like not assembly. Oh, I see. You can store floats in integer registers and do some bitwise stuff if you know what you're doing. Yeah, you really need to know what you're doing there. Hashmap entry, undeclared identifier. Hashmap C. Right, that would be correct. It's hashmap underscore T. And then, oh, I see. Right, that is my fault. Because I'm using a string T, right? What I need to do is string lit. No, I don't think I can use const here. I think I need to use this. So, choop, choop, choop. So just to explain this macro right here, it's basically just creating a new instance of this string struct right here to create, you know, an str string. Hashmap get value undefined. What? Right. Typo right here. Cool. Assembly is something I'll probably not get around to trying to learn unless I'm feeling masochistic. I mean, it can be fun, right? But yeah, I get why it's not everyone's cup of tea. Okay, what's your position on FOSS? Like in free open source software, or like, I'm not very good with acronyms. I usually hate acronyms, so free software. Um, you know, so what I do like is, I see it that way. Free software, fine, right? If you do not rely or have to rely on an income, right? So let's say if you're getting compensation from somewhere else for the work you're doing, then by all means put your program up for free, right? Pff, whatever, do what you want, right? I do, however, like getting paid for things that I'm working on. Now, that said, what I do like is once you bought a program, I feel like you should be allowed to be able to do whatever you want with it, right? And that comes also with like, I really like when you buy a program and it comes with a source code included. That's fantastic, right? Because you bought the binary, you can modify it if something's broken, right? And or you can just wait for an update, whatever, and just buy the new version or get a version update. That's fine as well. But I really like it when source code is included in tools. However, I also don't really, I don't mind if the source code is behind a paywall. Let's say you get the program for free, but if you want to have access to the source code, you need to pay. It's fine by me, right? I don't know. I don't have like this one statement of things like, yeah, this is what you should always do with your software, and this is the way to go. It's just like it depends, but money and time, yes. I mean, if you invest your time, then yeah. Yeah, reverse engineering modern software, I can imagine, is a nightmare. Reverse engineering Game Boy games, however, that is fun. I also really want to write a disassembler. I already kind of got something working, which is kind of fun to do. But it's like, very simple compared to like x86, and especially very simple, as you said, compared to like the code that object oriented code generates, like the instructions it generates, rather. Like, I mean, best thing if you want to see my stance of it, you see the link to my Ko-fi page right here, right? So I do want to give people generally access to what I do on the streams and in the YouTube videos and stuff like that, but I did put it behind the paywall. So, because I do not have an income at the moment, and would be nice to get something a little bit out of it. That's all. Okay, I'm ready to run this in the debugger, I think, so let's give this a shot. So new hash map works, right? We know that, but let's break on, actually, let's go and break from here on. Great examples of open source. Yes, they are. Hey, Nick Warsaw. Hey, I was late today too by like 10 minutes or something. I don't know. But yeah, great examples of open source. Like if you mentioned Chromium, I wasn't that done by Google, right? So again, those people that worked on it probably got compensated based on that, on their work, right? I mean, but yeah, there definitely is great examples of open source. Like this debugger, for example, the RAD debugger, right? This one is open source as well. And it's, well, it was the company RAD, but Epic Games bought them, so now technically it's Epic Games. And the people that work on this debugger, again, they get compensated by Epic Games to work on it, right? So, and if they're willing to share it for free and open up the source code for free, then yeah, that's great. Awesome. Okay, so we have hash map insert values. You know what? Yeah, let's go this way. So we have symbols, right? This is our hash map right here. I introduced padding again. Ah! I mean, open source being abandoned, I don't necessarily mind that because like the code is open, just take it and, fix what you need to fix if you have to. Now, I agree that's not always feasible because like, code can be quite horrible and especially modern code, and you might have to sift through a lot of things, but also I don't get this. Like some people are like a bit jumpy when it comes to libraries and some open source code when they're like, "Oh, this hasn't received an update in like 3 years," and I'm like, "Yeah, but if it works, why do you care? Does it matter?" Like, you know what I mean? There seems to be this weird thing like where everyone expects every project to have constant updates all the time, even though that project is technically done. So it's like, ah. Oh yeah, I heard about the nightmare dependency trees in on the web. I saw like a funny screenshot about like a call stack in the web. It just gave me nightmares. What would it take for you to write something like FreeBSD or Haiku? You mean like write software for it or write an operating system? Oh, writing an OS. Honestly, I would love to attempt that one day. Like, absolutely. But okay, I have like this master plan, right? But so this is my plan, right? Let me go to the camera. This is my plan, and I'm like here, like in the very beginning. So that's why I try to do this Game Boy stuff and trying to attempt to learn like how to write assemblers and tools and disassemblers and an emulator at some point, and then learn assembly, see how I like that. Then I would like to attempt to write a programming language specifically for the Game Boy, which would be quite interesting, with like features that are specific to the Game Boy and that kind of stuff. That then like teaches me how to do compilers and that kind of thing. And yeah. And then I would slowly try to increase from the Game Boy CPU to like slightly more complex CPU and then see where it takes me. Maybe something ARM based or whatever. I don't know. Yeah, searching for documentation, debugging drivers, and all that kind of stuff. Yeah, that will be horrible, but I think like the trickiest part would be to get like graphics chip working, right? Because most of the things are like a lot of the graphics cards or graphics chips just come like with a binary blob of drivers. Life is short? What do you mean life is short? Life is long. It's like 80 years or something. Hopefully. Right? It's like... I mean, if I aim for 80, I have like a little bit more than halfway to go. So, geez, like that's an eternity. Yeah, I mean that's the way most OSs go, right? Just forking Linux and then going from there, and that's why you have all these different Linux distros flying around and all kind of stuff. It's probably a good way to start things, but then I don't know. I wonder if it's worthwhile trying to go with Linux and understanding the ins and outs of Linux to write your own OS, or actually just try and attempt and write a simple kernel yourself and then build it up from there. Hey, if this dude from who was it, Temple OS, got it done right, should be possible. What benefits would you justify spending 10 years writing OS? Do I need a justification? Personal fulfillment, learning a lot, right? Maybe producing something that can get used somewhere else because of your experimentations that you did, right? If we go from, you know, I very much don't like this attitude of like, oh, why would I be doing this if it already exists, right? It's just like, if we were stuck with that, we still were riding around horses, probably. You know, so I think OSs are too similar. Yeah, I would agree in that. I would like to work with like try to experiment with some different ideas as well, instead of just doing what's already there, right? I have no clue what that would look like yet, though, because, like I said, I'm at the very, very beginning stage of what I actually want to have in the end. But if I could fork Windows, I would. Yes, I would too. And I would delete freaking Copilot. I would delete the search. And whatever they did with the Explorer here, like what the deuce is this? Writing kprintf was enough for you? Yeah, I mean writing printfs. Yeah, it's a challenge in its own, I guess. Okay, entry. So we have bucket here. And that has an entry, right? Hang on, I need a refresher. Right, and we have multiple buckets. So where is base? So this. How many do we have? Symbols capacity, right? There we go. Did I mention I love this debugger? So these are all the buckets. Actually, there's a lot of other things going around here. Let me put this in the watch list instead. So we have symbols, right? And let's have symbols base, right? And that will be an array of symbols capacity. Okay, for kernel printf. Okay, sorry. See, I don't find that scary. There's always discoveries going around, right? And if you really don't feel like it, you might as well just abandon the project and move on. And you know, that's not wrong. At least you learn something along the way. I mean, all that knowledge is valuable, right? In any kind of way. Okay, and then we have item. I mean, in my sense, what I will get out of it is a lot of YouTube videos that I can make, right? For someone else to learn something. Do I know the meaning of your name? Red Zone? No, I don't. But feel free to enlighten me. Okay, so insert hash map item. We're actually getting an item back, and the value of that item points to the value that we actually handed in. So that is good. That's a good sign. Now, probably should have... no, there we are. This is a bucket. There is our entry. And the key is foo. And the hash is right here. And next is 0. And there is indeed the item. Right? Yeah. Pointing to the right thing. Cool, so this worked. Let's add bar to it, right? So bar is now an item which points to this address, the value, which is value 2, as specified right here. Fantastic. Whoop, there we are. There's our other entry, bar, that's the hash. And we have an item right here. Cool. And then we're trying to add bar with a new value. I'm wondering if instead of like not allowing it, I should just change the value. Oh, I mean, you can do that. It's up to the caller to do it anyways. So, okay. So item should now be... It's still pointing to value 2. Okay, cool. So it found the old key and returned that to us. Hopefully. I should have maybe looked for foo. I mean, I can step through the code at some point and then just... Okay, anyways. So now we're trying to find foo. We found foo. We're trying to find bar. We found bar. And then we're trying to find yo-yo, which we do not have, so we return null. Cool. That seems to work. On Linux, there's 128 bytes of free stack space if you're in user space and you're in a leaf function. Okay. All right. A very specific name then. Interesting. Yeah, honestly, I would have to Google that too. I do not know. Oh, I see. Oh, makes sense why it's called a leaf function then. I didn't know they had a name either. Interesting. See, you learn something new every day. I mean, is it just called a leaf function because of the way parse trees are being done? I guess for call stacks, if you look at them as a tree, and then, yeah. Computer science names are fun anyways. Also get redefined every few years. Okay, so we do have a hash map. It can do the basic things, right? Insert and get an item. So let's check the old project, whether we get something more fancy as well. No, hash table insert, hash table get. Yeah, that's just it. And the cool part about the way we did this now with the hash map item is that we can actually exchange the value once we found it without having to re-add the item. Or if the item already exists and it has a value, we can then decide, okay, do we want to update that value or not, right? And to do this, we just write into the value section of hash map item. I kind of like that. That's kind of cool. Okay, how long did we already go on for? 2 hours. I still want to go up for a little bit, but I do need a 5-minute break, I think. I'm just going to make myself a new coffee and maybe grab a quick bite of something. And then I'm going to come back. And when I come back, I think what I'll try to do... I'm wondering if I should continue with like the symbols table already, but I don't know what the symbols would look like yet. Or if I should work on the dictionary that I wanted to do with the, what's it called, the Wagner-Fischer algorithm. Or maybe I can work a little bit more on the tokenizer. Okay, so yeah, three things we could do. So, no, implement symbols types, right? So 3 things we could do. We either implement the symbols types. What I mean by that is symbol definitions, right? Unresolved symbols that we kind of need to keep track of. Or we can do so symbols, unresolved symbols, aliases, right? I had a feature of defining aliases for certain things. Think of variables sort of kind of thing, right? Keywords that we need to add to the symbols table. I mean, we don't need to, but I do want the keywords in the symbols table as well. So I just need to do the hash lookup for keywords as well. So we can do that, or we can implement number parsing and stuff like that for the tokenizer. Because at the moment I'm just returning the number as a string and, you know, do not try to parse the value. And in before I did that in the parsing stage, but that just made the parsing code much more complicated. So if the tokenizer can just return the right token with the number already as a value, that would be kind of helpful. And there's also some other token types we might want to add. Like I said, I do want to do arithmetic stuff, so plus or minus for labels, right, to get the right address, things like that. So I kind of need to change these tokens. So at the moment, a negative or positive prefix will just be changed to a number, right? Sorry, where's the number token? It would just return number. But now I sort of need to make them separate tokens if I want to have plus or minus operations, right? So we can do that. Or what did I say? Or dictionary of symbols. This is for error messages. Right. So I kind of want to store the strings somewhere, right? Just put them in like another arena that just has all the symbol strings in there. And then if the user writes, I don't know, let's go here, right? We have an entry point, but what if here, write v blank, right? So, and then we want to jump to write wait v blank, right? But what if you write wait x blank, right? Which doesn't make any sense. Then I want the error message not just to say unresolved symbol wait x blank, right? I actually want to say unresolved symbol wait x blank. Did you mean to write wait v blank, right? Because those are fairly close together. So kind of to give the user a hint of what they might have wanted to write. Have you tried programming with a background image? No. I don't know why I would want to. Yeah, I don't know. I've seen some people do that in the terminal and stuff, but yeah, I found that a bit distracting, but yeah. The tail is probably referring to that each function retains the execution context from where it was called, essentially building a tail. Could be. Bad idea with a background image. Okay, anyway, I will decide what to do while I make my coffee. So, yeah, I'll take a 5-minute break. See you all in a bit. Whoops, sorry for the slight delay. Ooh. Right, I said I'm going to think about what I want to do. I've not decided yet. I mean, in any way, I think what would be good is to build the dictionary for the symbols. Just because I need a way to store all the strings anyways, right, for symbols. If I don't have the dictionary, I can just use the arenas and just plop them on there. Sorry, the global arena. Otherwise, I need a separate one if I want to iterate through all the symbols in the list to then calculate the edit distance for the Wagner-Fisher algorithm. Yeah. Yeah, I guess let's just build a way of storing strings into an arena. I mean, that's fairly simple, I suppose. Let's say do I want to copy or insert? Let's just name it copy string. We want it in a memory arena, right? And we have another string that we want to copy. And that string can just be made out of a string literal or a base address and a length, right? So let's say we have like a symbol in a file, right? Where is it? There it is. So let's say we have this symbol right here, like entry point, for example, right? So the first time you build a string, it actually points into the memory of the file that you just have opened, right? So this would be the base address here, right? Pointing to the E, and then the length of whatever this is, right? And as long as the file is open, you can just refer to that specific location in memory, right? Because, hey, you have the file in memory, right? So no need to copy it around and whatever. And that is actually not that bad of an idea of doing without copying the string, because like if you just assemble one file, a single source file, you have it all the time in memory anyways, right? So you can just refer to that point during the whole runtime of the program because you're just passing one file and that's it. But then when you have include files, you probably don't want to open, like, keep all the include files open that you also have to parse, right? That would be kind of wasteful. So you probably want to then, with symbols that are defined within the include files, to then actually copy the string and just hold on it to memory somewhere. Or the other way of doing things, you know, if you ever want to change the way of how your file is read, so you don't hold the whole file in memory, but you just want to hold like a certain section of it in memory or whatever. If you want to change the code for whatever reason, it would probably be good if you have the ability to copy these strings, from file memory into your dictionary or whatever it is where you're holding those symbol names into those strings. So let's just start with copy string, right? We're taking one value and copying it somewhere into an arena. That's it. We're creating essentially a copy, an instance of that, and yeah, the copy will be put in the arena. Whatever arena that is going to be, doesn't matter. So we probably want to insert for value base not null and value length not null. Right? And then you want get memory arena buffer, right? And that is arena. And then we need the size, and the size is just going to be, well, it's just U8, right? So value dot length. And that will be this. Right. If base is null, actually what we can probably do is say results, right? And do I need to zero the result? Nah, let's not. Can do result.base, result.length. Actually, if it is not null, then we can say result.length equals value.length, and then just return result. Right? Okay, again, acronyms. What does DOD stand for? I'm really bad with acronyms, so that's. So yeah, so if this is null, then we just return I mean, let's just do this, whatever. Doesn't really matter. Or what we can do is just say result base is not null, then value length, otherwise 0. How about that? Oh, data-oriented design, like using structs of arrays and okay. Memory arenas are a common container for data-oriented designs. Okay, I didn't know they were common for data-oriented design, but so I'm not trying to be overly, at the moment I'm just hacking away and just trying to finish something, right? So I'm not working by some specific design or whatever. However, I do like to try and be data oriented at some point, at least where it makes obvious sense to me immediately, right? So with memory arenas, I just like the simplicity of it, right? Because I do not have to worry what the heap allocator is doing, right? Things like that. I could have written my own heap allocator or whatever, but I just like the simplicity of it, of treating like a block of memory like a stack, right? You're just pushing and popping things on and off of it. And in this program specifically, most of the times I will just be, putting things into the buffer and never removing anything. Like if you think about it, for example, the symbols table, right? The reason why my hash map has no remove function is like because I never need to remove a symbol, right? Either there's a symbol defined or there isn't throughout the whole lifetime of the program because I'm just parsing code. I don't see a reason why I would ever want to remove a symbol from a symbols table while I'm parsing a file, right? So yeah, I mean that is a good point, right? You can make like educated guesses about certain things, but then once you start measuring and figuring it out that for like in your example the linear search is faster, then that's perfectly fine, right? So what I would like to do is just I try to code in a way where it makes sense to me at the moment. I mean, like, I know it's like hard to describe what that means. I just sometimes look at things and like, okay, I think this way would be the best way of doing it, and then I'm just doing it, right? And then if it turns out to be a little bit of an issue or whatever, then I like to measure performance of it, and then maybe do a separate implementation, and then see how they compare and that kind of stuff. It's probably not the best approach, but I don't know. My approach also always changes. I mean, this is certainly not how I would have done things back in the day when I used C Sharp, right? In a different company or whatever. Because then you do all those OOP specific things, and in C Sharp specifically, you just allocate memory willy nilly whenever you want to. Because, like, why do you care? The garbage collector takes care of it, right? Until everyone loses their shit when suddenly, like, there is a garbage collector pause and they're like, oh no, why? It's a whole different story, but. I mean, one of the obvious ways that I try to avoid is like, I try to avoid doing too many copies of things, right? That is something I do not like to do, and I know this is kind of ironic coming from me just writing a copy string function. But hey, if I can avoid it, I avoid it. Have you tried making a project where all memory is global and static size? No, but I assume I will once I deal with the GameBoy stuff, right? Because there's just a fixed amount of memory and it is accessible to everyone. But I mean, speaking of everything being accessible, one thing that I do is like I include C files into everything, just so every code can refer into everything. I do not like the separation of like private and public functions and this kind of stuff. Right? But in terms of memory itself, no. I mean, I guess the stack is sort of a static size, right? At least in this project. I think I've set the stack to 1 meg. Where is it? Yeah, here. So I'm reserving 1 meg of address space and also immediately committing it. And I have set the stack probing size to something ridiculously large to no longer have stack probing, so the stack won't grow. Right. Global data is far away, so the instructions will use more memory to encode the address instead of index on the stack. It is what it is. I don't know. I don't think that is something to worry about for this program, to be honest. But okay. Where was I? So I did a string copy. So if I do this dictionary feature, right, I also kind of want it to be optional. So if it's disabled, it will just use the global memory arena to put the strings in there and like for the symbol names and just hold on to them. But if it's enabled, we can change the arena into something that's like specifically like a second arena, basically, that's just for the symbol names and like treat it as a dynamic array sort of thing, right? But then, oh, also I haven't copied the string. Dear Lord, what am I doing? Lol. Sure, let's do it this way. So length equals value length, and then what we want to do is we just do a mem copy into results base, and we want to copy value base, and the length will be value length. There we go. I can decide whether I want to make it null terminated or not, right? So I could actually do this, and then in the end, result base value length, no value length, and then sure. So let's say we have a string. Actually, we already have the input file name up there, right? So let's just copy and then copy string into the global arena and then say input file name, right? Yeah, that's fine. Okay, cool, perfect. Right, locals. So copy. Cool. And then we probably want to check copy base, copy length, whoops, and it is null. Excellent. I'm just wondering how I want to do this. Okay, let's just name it dictionary. Right. End of GB assembler dictionary. Dictionary. Nope. Watch dictionary being used somewhere on Windows already, I bet. Dictionary H no, C, and then Let's just put this here. Include parsing dictionary. So there is now oh right. No, I don't have error highlighting. Like I said, I like to make my life extra hard. So, okay, what I want to do is kind of, like I said, the dictionary option should be optional because, like, iterating through all the symbol names within that dictionary to, like, find the closest match to then present the user an error message of, like, hey, did you meant to type this? Can be slow, right? Because you have to go through the whole dictionary. And, I mean, there's ways to, like, terminate early. Especially with that algorithm that I'm going to use, but I just want it to be an optional thing that you can enable or disable with Command 9 flags at some point. Now, if that feature is disabled, this dictionary memory arena should just, be the global arena. And then we just put everything onto the global arena, whatever. But if it is not, then it should be like a separate arena that is allowed to grow with all the symbol names that it needs to. So I kind of need a way to like specify, hey, use this arena or use a new one, right? I also should at some point specify for arenas whether they can grow or not. So maybe it helps if I just write down what the API should look like, right? So I want a dictionary, right? I call new dictionary, and this will be the global arena, right? The global arena can be where the dictionary struct lives. That is completely fine, right? Or I could just simply specify, hey, if I put in a null, then allocate me a new arena for, that's actually not a bad idea. Maybe I do that. And then I can simply say if this command line option, called use dictionary is true, then we use in that. Otherwise, we just pass in the global arena. Because I still need a storage for the symbols for include files and stuff. So I still want to use the same dictionary. But then depending on the feature, see which arena it actually is. Or, you know, I can have the whole arena allocation code outside of this and just simply pass in the arena, to be honest. Maybe that makes more sense. It makes the calling code a bit more complicated, but whatever. It's probably better than just, you know, oh, here, this behaves different if this is null. I don't know. Yeah, exactly. Why null? Why not give it a valid arena? Yeah, that's what I was thinking. I'm just spitballing here. But then in the end, I kind of need to, because, so if I go with the global arena, then I cannot just, you know, use the dictionary feature to actually iterate over it. So maybe I should add at least a flag. So I need to not do this in the calling code. So if I have something like, you know, find similar or whatever, right? Find a symbol that is similar to this one. Right? If this is using the global arena, I don't want this to work, and I just want it to return the symbol. Because like there's a whole bunch of other things in the global arena as well. No, but that's kind of shit, isn't it? Because then in the calling code, I still have to be like, hey, if, you know, if I compose the error message, I need to know So like I said, this feature is only for error messages, right? So let's pretend print symbol error, right? strt symbol, right? So you want to, let's sketch this out for a moment. So really what I want is options, find similar, right? Then here call find. So actually, so similar, find similar symbol, right? I mean, there also is kind of an issue that it can return more than one. I have to think about that as well a little bit. I can use a little arena space for that one though, and then rewind. That is fine. but then you would say print error, hey, %s is wrong. Did you mean this %s, right? So you then have symbol and similar, right? Otherwise, you just do print error, hey, this is wrong. I mean, those are not the exact error messages, right? But I want something like that. I mean, based on the command line option, I know that I can then iterate through it, right? Because I use a new arena, I suppose. What I could do is like have a flag in here saying whether find similar is enabled or not, right? So I don't need to pass the options around. So that would be let's call it dict for now, right? Dict. I guess that feels okay. And it has to work with the global error handling. I'm not sure if this feature is overkill, but I kind of like the idea of it, you know? I think I do it with a flag. I think that's all right. That seems all right. Yeah. Hmm. Okay, I do not like Boolean flags like this though, so I'm just gonna do dictionary flags. Not struct. Enum. Sure. And then dictionary T, result, get, I forgot the macro, get arena type, right? Arena, dictionary T, there we go. And if result is not null, then result arena equals arena. Right, these should be flags. Okay. So it either is something that you can actually search because you know all the items are in sequence in there, right? So it's full of strings. Actually, I probably don't need this copy string here because I also want to store the length of the string in the dictionary itself. Okay, but what I meant to say, so this either just becomes, something that is searchable because you know everything is in sequence, or it just becomes a simple reference to an arena where you dump all your strings in. Whatever. It's just basically some kind of storage. And you can either search through similar entries in it or not. That's it. Okay, find similar. But finding similar ones is a bit... That's quite a mouthful. Right. So... So the search will then find you similar ones, right? So there's not always going to be one option, right? There might be 2 or 3 or whatever. I can limit it to something, I suppose, but haven't thought about it yet too much. We'll see. So you just want an array of items, right? And then you also need the count of how many items you actually have in there. And Yeah. I'm going to be annoyed typing all of this, though. Oh, well, I only need to type it once for the error message, so it's fine. And let's call this search similar. Right. In this dictionary, and so if, hang on. Okay, I do not need asserts here, but I do need asserts here. So assert dictionary should not be 0, and value base should not be 0, and value note length should not be 0 either. Then if dictionary flags and no, this. Then we can search. Otherwise, okay. But that's kind of. No, it's fine. The search result can just live. Can just live here, right? We can just say result equals this, right? And just return the struct. The struct is fairly small, so that is okay. Let's just return it. And then here we can actually fill up the array, and however much we find. And for that, I can just use the end of the arena. No, but then I need to make sure it's also freed at the end. Why not just flags equals searchable? I might add different flags at some point, who knows, right? I don't want to go in and edit this code, so I'm just doing it this way. I don't think I probably need different flags, but we'll see. So this is a bit annoying now. So because like if I have like 5 strings in this dictionary and I find similar ones, right? Let's say 2 and 4. Then my array would look something like str2, str4, right? That is the next item. But I need to have space, right, for 2 items then. So I can use the dictionary arena like at the end of it to like attach the array there. But then once the error is printed, I need to kind of rewind it so I can reuse this particular area for like other strings that might come in, right? So string 6, string 7. Or I wonder if I should design a similar API as Windows file searching, right? Because I'm also thinking about like building the error string in the end. I probably want to have something like, did you mean colon, right? And then print them one after the other. So maybe something like this would be better. Let's say find first similar, right? And then you're getting like a search handle. Right? And you pass in whatever you're looking for. And then you can have find next similar. right? And then you kind of build your string as you go. And then in the end, like to free the memory again, you can just say finish search, right? Or end search or whatever. Or, you know, it's basically like the pattern begin, do, right? And then end. Basically like that. I think I kind of like that. And then I really just need to return the string by find next similar, right? And not worry about an array and stuff like that. And if I already found 5 items or whatever, I can terminate early. Yeah, I like this. Okay, I'll do it this way. I'll do it this way. Okay. Let's call it search handle. Search handle, right? And what do I need to know? Well, I need to know the current position, right? Actually, no, just the address. Maybe I should first specify how to even add items to it, so I have a clearer picture of how to actually search for them. How about that? So let's go on with that. So void dictionary add string, right? And we have a dictionary t, dictionary search dictionary not now, and then so what do I want in there? Yeah, could do that as well. Find similar with a null string. We'll see. I have not decided yet, so So I want all the characters, right, of the string in there, which is where the base will be pointing to, but maybe I also want the length first. So really, oh, we also want value base should not be null and value length should be null. All right. Value length, maybe +1 for the null termination. So that way we have a U64 for the length first, right? And then we have the strength, and fine, we store the null termination as well, whatever. Let's do it this way. Then we have a U64, right, for the length. That's how we start. And the length will be value.length. We do not count the 0 termination. Okay, if length right. Oh, sorry. Destination would be length. Although I don't think I need to do this, I can just do this. It looks dirty, but it works. And then we have value base and value length, right? And then, nah, come on, that is that is dirty, right? Let's not. let's make our intentions clear, right? Say data, right? And the data will be unit pointer with length +1, right? And then data, and then I can also say data value length and have the null termination in there. Okay. Do I need to know whether this worked or not? I mean, I could just return the copied value, I suppose, if I want to reuse this for something else. or continue using it. Right, after adding it to the dictionary, I then want to refer to that one instead of this one. So might just be nice about it. You know what? Let's do it this way. And then if the string is basically empty, I know that like it hasn't been added. So then here, really, let's say U64. Right, and then I can say length equals value length, and so length equals let's just do that. Okay, and then the data will be base actually no, I can just say length plus 1. That's fine. Okay, copy the data in there, do data this one, right, and then result base will be data. There we go. What? Oh, because of this one. Okay, fine. Just wanted to comment this out. Let's try this one first, and then I'm gonna worry about the searching part. Okay, let's put this into the C file. Right, and then we just need the definitions here. Okay. Okay. Let's just use the global arena for the test for now. That's fine. So we have dictionary, right? Dict, whatever. New dictionary, and we just pass in the global arena for now. And our flags, we don't have flags for now. Let's just make it 0. And then right, strt. So let's call this value. Right, foo. And then strt value 2. Right. And then so we call this one new. Dictionary add string. We call this indict, and we put it the value. Right, and then we have new 2. Dictionary add string, dict value 2. Okay. Dictionary might be the wrong word for this, but I mean, it's just a buffer, really. It sounds fancier than what it actually is. Okay. And I want to check the basis for both of these in the end. Okay. Builds. Hey. What's up? Do you want me to mute? Okay, 1 second, please. Okay. I was a friendly reminder that I also need to take my dog out soon, so... So what is it complaining about? Oh, right. Do just need this? Yeah, fine. Unreferenced local variables. Yeah, we know. Okay. Yeah, that is fine. Okay. So we're adding foo, right? Oh no, so we're creating foo, sorry. So value and value 2, right? And then we're trying to add it to the dictionary. So the position of the arena should grow. And indeed it does. And new is now the string foo, but with a completely different base address. So that is nice. And then new 2 is bar. Hang on, where's value 2? Am I blind? Oh, up here. Also with a completely different base address. Nice. Okay. And new, new dot length, right? Oh, right, yeah, you can't index into this, but you can index into base. Right, so that is the 0 character, but now if we do +1, no, really? No, hang on. Plus size of... What? Oh, you can't do that. Damn. Okay, whatever. It doesn't matter. Okay. Now, I just wanted to check if the other value came directly after it, but I'm sure it did. I just... doesn't matter at the moment. It's fine. They have different addresses. That's fine. I wanted to build some diagnostics for the arenas anyways to kind of... No, it won't be coming directly after it. Because my default arena is aligned by 8 bytes, so that's why it was 0. I'll have to go a bit further. I can probably remove the alignment for now for debugging purposes. It's fine. It's fine. I want a new arena for the dictionary anyways, right? And there I can set the alignment to 0 or something. I'll see how to do it. I'll figure it out. I'm wondering if the arena is even the right data structure for this. You know, I thought about this a little bit more. Yeah. I might just unnecessarily overcomplicating this, to be honest. And really, like, these dictionary entries, really, I could also just make them a linked list pointing to the next element and then traversing that. And they're somewhat in sequence if they use the arena, right? But then I can do that with any arena, so I don't need the flag, really. Why didn't I think of that before? And that way you can just be like, hey, we can just put everything into the global arena and just link them together as linked lists, essentially. And if we do want that little speed so they're contiguous in memory, we can just create a new arena and only populate them with the entries, so we know that next element is just basically one alignment away, which should help it out. Yeah, because then you're accessing the memory in sequence, so it will actually help out with the cache as well and everything. So I should just do that. Why did I worry so much? Okay. Okay. Yep. Yeah. Okay. 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 Struct dictionary entry, right? Dictionary entry. And dictionary entry next, right? And then we have, you know, in this instance, I can just do that, really. No, let's do it this way. Base 64 length. No, let's just do this. Right. And then and we don't need the flags. We can still do add string, right? And then don't need flags, and let me just copy it so I don't forget. My brain, dude, my brain. So get memory arena type, which is just the dictionary, which is okay. We have the arena, and instead of flags, what we're having is, what did I name this? Base, right? So base will be 0 because there's no item in there yet. Could have a count, right? Number of items. Result count. And then dictionary add string, right? So this is still okay. We still have a result. That is fine as well. And then so we want a dictionary entry. Entry. So the size of the dictionary entry plus the length of the new string, right? So for the new string data. So that will be the entry size. And this can be a dictionary entry, right? Entry. So if entry is not null, then maybe didn't I do this already? Yeah, I did. So basically similar to what the error list was. Okay, so then I actually want the first item and last item, right? So I don't have to traverse the list. First, so we can start iterating, and last, so we can add faster, right? And on the interest itself, we just need next and the value. Okay, so first and last, right? Cool. So we get dictionary. Okay, this is still okay. And then we have entry, and entry next is 0, right? Entry value base is, well, entry value length will be value length, and then entry value base is U8 entry plus 1, right? Because we're going to the end of the entry, and this is where we store the string. And then we still do this shebang here. Copying this into, nope. That is the base. And we're copying this. Oh my lord. So value base to entry value base with value length, right? And then this data becomes entry value base with value length, and then we set that to 0. Okay, cool. And then that is the entry. And then our results will just be entry. Entry value. Okay, but then if dictionary first, no, dictionary last. If that is null, then dictionary first equals entry, dictionary last equals entry. Otherwise, dictionary dictionary last next equals entry, and dictionary last is entry. And then I might not even need a find function, to be honest, because it's just a matter of like iterating over like, you know, first and then getting the next item and just doing that. Oh, I also didn't increment the count, but dictionary count plus plus, there we go. So similar to what I did with the errors, I just print errors, right? So do something like this. I mean, what I do need is like a print symbol error method, right? Function, sorry. But what I definitely need is the... So I did this little test already. To get the distance. Okay, let's take this and adjust it to what I need. So this thing right here is the Wagner-Fisher algorithm, right? Just did a little test already. This does not have like the optimizations for space yet, so it uses the full matrix, which I think you can get rid of, but I won't be doing that today. I really just want to see if this works, and then I can optimize it later on. I probably also want to terminate early. If like the edit distance is too big, I just give up early, right? But yeah, I'll figure that out later. Brain work. Okay, so what I do need, so get edit distance, right? And we want to work on a string source and string target, right? We do not need, well, we kind of do need that. Right, so source length plus 1, so this will be just source length plus 1 and target length plus 1, and then okay, but we're doing this with an arena, right? Arena. Position, get memory arena position, I think. Oh, come on. Yeah, get memory arena position. Okay, I'm learning my own APIs. Fantastic. Arena, right? So that is the position because I want to rewrite afterwards. So those will be the edits. So edits would be, instead of malloc, we use get memory arena buffer of this arena, but still the same size. That is okay, right? We can do long star, although long, no, let's use fine S32. Set all to 0, fine. Mem set edit, yeah, that's okay. Set edit distances for empty strings. That is still correct. So I know there's like some syntax you can use for dynamic arrays in C99, but this is one of the limitations of the Microsoft Visual C compiler because they never implemented this stuff. Thank you, Microsoft. So I have to resort to like this nonsense here. It's just, yeah, it's horrible. Basically like pointer arithmetic, right? For two-dimensional arrays, which is, yeah, fun. Okay, set edit distances for empty strings. So this is the target and the source length, right? And then we calculate the edits. So we're going row by row, right? So first row and then column through. Substitution, yeah. So this algorithm like basically works the same. This is completely fine, right? And then we have the result itself, which beautiful, beautiful syntax. So S32. I might actually change that to U32. We'll see. It should actually not be. Why would it ever be negative? It makes no sense. So let's change this to U32, right? I like to use unsigned where possible. So, okay. I don't like using that, so all the longs is a U32. We use my type defs. And then int, whatever, can also be a U32. Right. Okay. And this will be U32 results, right? So this is the smallest edit distance between those two strings. And what I need to do now is basically give up the memory that I allocated right here, right? So we're gonna say rewind memory arena to position, I think. Is that what I called it? Oh, geez. What did I do? Rewind memory arena to position. Yes. But I'm too lazy to type it, so copy pasta it is. And then position, right? So this is how we rewind. So now whatever we used here, we just put back. Whatever. I'm not even sure if I need to set all to 0, to be honest. Because, like, okay, you know what? To do most likely not needed at all. All right. And then we're also gonna say to do make optimizations to limit the size of the algorithm, because I know we do not need the full matrix. I think we just always need the last row. So you can kind of do this in one go, but I haven't looked at it too much yet, so, and we've been going on for almost 5 hours, so, and I need to walk my dog, so this is probably the last thing I'm gonna do, and then return the result, right? So now this is the algorithm to get the smallest edit distance between two strings. So let's just make a function that prints out similar things from the dictionary, right? Just as a test, right? Print similar strings, right, from the dictionary. Similar to whatever we pass in here. Let's mark this as test, so I know I need to remove it, right? Remove me. Okay. So, let's have a quick assert for dictionary. Should not be null. And value base should not be null. I mean, probably not needed because this is just a test, but, you know, should also not be null. Then, if dictionary count is null, then we have nothing, right? So we just give up. Otherwise, it's dictionary entry, right? So we get the first one, right? And then we can find the edit distance between them. We just reuse the dictionary arena. And we want to find the edit distance between what we have and... So that is the source? No, that... I don't know which way rounds they need to go at the moment, but we'll figure it out, right? So, and then... I mean, it probably really doesn't matter. And then current value, right? Because, yeah. So between value and current value. So this will give us the edit distance. Distance, right? And let's say we want to limit ourselves. I don't know, to max edit distance 3, right? So if distance is bigger than max edit distance, right, then we're just going to continue to the next one. Actually, right, let's do it this way. To do print, right, I'm going to think about the printing in a second. And then we have current is current next, right? And we do this while current is not null. Okay. So then printing, yeah, my printing facilities are a bit shite at the moment. Well, I guess we can use string format. Yeah. So get edit distance will free the position right here, right? But then I need to, okay, right. So let's get memory arena position. Dictionary arena, right? And then we can call string format. Similar, right? We say dictionary arena. The format will just be if it's not null, then we're just gonna print this. And if it is null, we don't want the... let's do it sized. We don't want the comma. Actually, I'm gonna stop. Right. And here we're gonna pass in current value length and current value base. And my dog is barking. And here we have right output. Similar, right? And then we can say rewind memory arena to position, dictionary arena, and we're rewinding to pause. Okay. And then here we're gonna say, actually, let's do a whole nother string format, right? Okay, we're getting this, okay. And here we're gonna say strings that are similar to %s, right? And that will just be value length and value base. Then we're writing this to the output string, we're rewinding. Probably don't need to rewind, but whatever. It is done now. Well, I mean, this will not account for the case where, you know, where we only have edit distances that are bigger than this. Let's fix that real quick. U64, similar count is 0, right? And then here we can just, whenever we print out, we actually found something. Similar count plus plus, right? Oh my god. And if similar count is 0, yeah, I don't think I really need to rewind. Let's just rewind at the end, whatever, right? This is fine. Then we're just gonna write none. Okay. Builds. Okay, what did I do? Oh, right. Right. This would be source base and target base, right? Similar heights previous declaration. Ah. It indeed does. Let's just call it message. Right, and then fine, just reuse it. I don't care. Okay. Cool. Syntax error. What did I do? Right, I probably can't use a string literal const here, so let's just do that. Oh my lord. Okay, cool. Okay, almost done, almost done. we have a new dictionary. It now doesn't need to take in anything, right? We're adding these strings to the dictionary, right? And then, what was the test called? This. Right, print similar strings in this dict. And let's print similar things to do, right? Oh, string literal. And maybe print similar strings to czar, right? Actually, buzz. See what happens. And then we can print one to, I don't know, whatever, right? Okay. Oh. Okay. Oh, I need to stop for that. Okay, all right. I'm being tempted with drinks here. Okay. Right, but we're really done anyways. So the only thing I want to do is run this, right? Probably should have stopped the other output. Oh dear. You know what? Let me do that real quick. There we go. Okay. So strings, pretend there's an S, that are similar to do is foo and bar, right? Those have edits that are smaller or equal to 3, right? So to make a do into a bar, you need basically 3 edits, where you need to change 3 of these characters, right? To get into that. For foo, you only need 1 edit, right? Same for buzz, right? And then a string that is similar to this, we don't have anything because, you know, the edit to get from this to one of these is just way too big. So there you go. I can probably have other examples. I don't know. No, let's say Mickey Mouse, right? And we can add Mickey House. No, actually we want to add Mickey Mouse, but we have Mickey House, right? So build on. Do I not have? Oh, right. Okay, I've uncovered a bug in my test thing. Ignore this. But basically, strings that are similar to Mickey House, right, is Mickey Mouse. So now you can print an error message saying, like, if a user types in Mickey Mouse, right, sorry, Mickey House, you can say, hey, did you mean Mickey Mouse, right? I'm sure Mickey is not spelled like that, but whatever. And yeah, cool. So this is how the dictionary would work, essentially. The next time, I'm just gonna finish this up and make this an actual error message. So it actually just uses this add error stuff, the global error handling. So whenever there's a symbol error and we put in like a specific symbol error with a name saying like, hey, we don't know what this name is, we can then say, okay, did you mean to type this maybe instead? What about that? Okay. I'm gonna end it here. The code will be available on the Ko-fi page. I will finish it up a little bit. Like I'm gonna clean it up a little bit before I put it up there. Like I certainly am gonna put like this back in, probably remove the test altogether. But this is essentially how the dictionary now would work. Okay. That's it. If there's any questions, let me know. I'll try to answer them if possible. But otherwise, I would quit the stream here. Hey. Yes. We're going out. We're going out, my little one. Yes. We're going. Do you want to say hello? All right. Okay. Don't lick my face, dude. No. Okay, I guess no questions. I will be continuing with this next time. So on brain work Wednesday 10 a.m. UTC time. I'm gonna be back at it again, and then I'm gonna look into some of the other things. So like I said, finishing up the error messages for dictionary stuff, so for symbol errors. And then I'll probably go into the token stuff before I continue with the symbol types. But we'll see. Okay. Thanks for watching, and see you Wednesday, hopefully. Bye.